Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about rationalizing denominators. This is a big, scary thing that a lot of math teachers want you to do, and we're going to take a look at it today and see if we can make sense of it. The question is this: why the heck does 2 divided by the square root of 2 turn into the square root of 2? We're going to jump into it. Let's get started. All right, so the first thing that we need to figure out here is why we need to rationalize denominators. Why is it even important? And many people, including myself, would argue that it's kind of an antiquated idea with the advent of calculators. However, I'll show you why it was kind of originally done in order to make things a little bit more simple. Now, we used to take, you can take any number that you like, and you can divide it. So let's imagine just another number altogether, maybe the square root of 5 this time. Okay. Now, the square root of 5 is kind of a hard number to picture. It's a number times itself that equals 5. It's a little bit more than 2, but it's an irrational number. Now, an irrational number is simply a number that is a decimal. The decimal approximation continues on forever, and it never repeats. So, for example, 1/3 is not irrational, even though it has this 3 repeating forever. Okay? Irrational actually means you cannot write it as a fraction. Okay? So a rational number is a number that can be written as a fraction. A irrational number cannot be written as a fraction. So you can't turn it into a fraction, which means that the decimal will go on forever and never repeat. So if I look here, I can imagine an irrational number. Again, think of it as a number a little bit more than 2. And a little bit more than 2, I could cut that into 2 pieces. That's what it means to divide by 2. And again, I can sort of imagine that. However big the square root of 5 is, I can imagine cutting that into 2 pieces. And that kind of makes sense. And it doesn't matter what number you put here. Maybe you make it a 4. I could imagine cutting it into 4 pieces, or 3 pieces, or 50 pieces. You can understand the idea of cutting something into a certain number of pieces. But now let's take a look at what happens if I try to divide this by an irrational number. What happens if I take 2, for example, and I want to divide that by the square root of 3? What does that picture look like? I've got some number 2 here. How do I cut that into an irrational number of pieces? Square root of 3 is about 1.7, and the decimal goes on forever. How do I cut it into an irrational number of pieces? It doesn't really make sense in our brains. Our brains have a hard time sort of getting around that idea. So the idea of rationalizing a denominator is a way of moving that denominator, or changing the denominator from an irrational number to a rational number, or a number that we are more familiar with, a number that we can imagine cutting into a certain number of pieces. Okay? So let's take a look at how we're going to do that. If we have a number, and again, the one, we'll just make one up here. So let's say 5 divided by the square root of 3. Okay? 5 divided by the square root of 3, again, is an irrational denominator. I want to get rid of that. And I have to find a way of getting rid of the square root part. And this actually goes back to our last video where we simplified square roots. And we learned that if you multiply a square root by the same number, it cancels out. So if I take the square root of 3 and I multiply it by another square root of 3, those will cancel out and I'm just left with 3. The square root goes away. But I can't just do that, right? I can't just I'm just going to change the denominator. You're not allowed to do that. So what you're going to do instead is multiply by a very creative version of 1. I can multiply any fraction I want by 1, and it isn't going to change anything. Okay, I can multiply by 1, and it's still the exact same value. I haven't changed it at all. But I'm going to use a really creative version of 1 here. Version of 1 I'm going to use is the square root of 3 divided by the square root of 3. Remember, anything divided by itself is 1. And look what happens if I do that. The square root of 3 times the square root of 3, remember we talked about this before, it just equals 3. It cancels out. I have a rational denominator. And in the top, I have 5 root 3 over 3. And you can always check to see if you've simplified your square root correctly. Again, type this into your calculator, type this into your calculator. It should give you the exact same decimal approximation. So let's see how this looks in other examples. Let's take 4 divided by the square root of 2. Now again, I have an irrational denominator. I want to get rid of that. So what I'm going to do, again, is multiply by 1. Remember, multiplying by 1 doesn't change anything, but it's going to be a really creative version of 1. It's going to be a version of 1 that will get rid of the irrational denominator. So I'm going to make it the square root of 2 over the square root of 2. And look what happens here. If you multiply those out, square root of 2 times square root of 2 is just 2. And on the top, I have 4 times the square root of 2. Now, some of you may have noticed, and I hope you did, we're not quite done. This right here can be reduced. 4 divided by 2. That divides out evenly, just gives you 2. So the last step you want to do whenever you're rationalizing a denominator is make sure that you simplify your fraction at the end. If you can divide out something, please do. And again, feel free to check my math. Plug this into your calculator, plug this into your calculator. It needs to give you the same exact decimal approximation. So that's it for today. That's your rationalizing denominators. You guys can do this on your own, practice it, and hopefully it'll give you some help. Stay tuned next time. We're going to be talking about special right triangles. I'll see you.